Evaporation is the process in which liquid water on the surface gets transferred to the atmosphere in the form of gas. About 80% of evaporation happens around the equator. This is because temperatures around the equator tend to be hotter, which speeds up the rate of evaporation. The other 20% comes from other areas of the ocean where the sun's heat produces enough energy to change the state of the water molecules from liquid to gas and from transpiration. And now for the next step. Here you go, Ryan. Thanks, Ryan. Condensation is the change of water from its gaseous form into liquid water. Condensation generally occurs in the atmosphere when warm air rises, cools, and loses its capacity to hold water vapor. As a result, excess water vapor condenses to form clouds and water droplets. The upward motion that generates clouds can be produced by convection. Convection refers to the atmospheric movement in the vertical direction. Basically, as the surface warms, it heats overlying air, which gradually becomes less dense than the surrounding air and begins to rise. As this bubble of warm air rises, it meets the cooler air and starts to condense, reforming liquid water molecules and precipitating in the form of rain. Some ways in which the warmer air can meet the cooler air in the upper atmosphere is through fronts. Fronts are boundaries between air masses. In the case of a cold front, a colder, less dense air mass lifts the warm, moist air ahead of it. As the air rises, it cools and its moisture condenses to produce clouds and precipitation. Due to the steep slope of a cold front, vigorous rising motion is often produced, leading to the development of showers and occasionally severe thunderstorms. For a warm front, the warm, less dense air rises up and over the colder air ahead of the front. Again, the air cools as it rises and its moisture condenses to produce clouds and precipitation. Warm fronts have a gentler slope and generally move more slowly than cold fronts, so the rising motion along warm fronts is much more gradual. Precipitation that develops in response to a warm front is typically steady and more widespread than precipitation associated with a cold front. And now for the next section. Here you go, Leah.
In the hydrologic cycle, transport is the movement of water through the atmosphere, specifically from over the oceans to over land. Some of the Earth's moisture transport is visible as clouds, which themselves consist of ice crystals and/or tiny water droplets. Clouds are propelled from one place to another by either the jet stream, surface-based circulations like land and sea breezes, or other mechanisms. However, a typical 1 kilometer thick cloud contains only enough water for a millimeter of rainfall, whereas the amount of moisture in the atmosphere is usually 10 to 50 times greater. Most water is transported in the form of water vapor. Precipitation is the primary mechanism for transporting water from the atmosphere to the surface of the Earth. There are several forms of precipitation, the most common of which for the United States is rain. Other forms of precipitation include hail, snow, sleet, and freezing rain. A well-developed extratropical cyclone could be responsible for the generation of any or all of these forms of precipitation. Amounts of precipitation also vary from year to year. In 1988, an intense drought gripped the Midwestern United States, disrupting agriculture because there was not enough rain to sustain crops.
Here you go, Maddie. Thanks, Leah. Let's talk about groundwater. Groundwater is all the water that has penetrated the Earth's surface and is found in one of two soil layers. There is one nearest the surface called the zone of aeration, where gaps between soil are filled in with both air and water. Below this layer, the zone of saturation, where gaps are filled with water. This water table is the boundary between these two layers. As the amount of groundwater increases or decreases, the water table rises or falls accordingly. When the entire area below the ground is saturated, flooding occurs because of all the subsequent precipitation is forced to remain on the surface. The amount of water that can be held in the soil is called porosity. This is the rate at which water flows through the soil, and it's also called permeability. Different surfaces hold different amounts of water and absorb water at different rates. Surface permeability is extremely important for hydrologists to monitor because as the surface becomes less permeable, an increasing amount of water remains on the surface, creating a greater potential for flooding. Flooding is very common during the winter and early spring because the frozen ground has no permeability, causing the most rainwater and meltwater to become runoff. Water that infiltrates the soil flows downward until it encounters an impermeable rock, and then later travels laterally. The locations where water moves laterally are called aquifers. Groundwater returns to the surface through these aquifers, which empty into lakes, rivers, and oceans. Now for transpiration. Transpiration is the evaporation of water into the atmosphere from leaves and stems of plants. Plants absorb soil water through their roots, and this water can originate from deep in the soil. Plants pump the water from the soil to deliver nutrients to their leaves. This pumping is driven by the evaporation of water through small pores called stomates, which are found on the underside of leaves. Transpiration accounts for approximately 10% of all evaporating water. Here you go, Sterling.
Runoff is the movement of land water to oceans in the form of rivers, lakes, and streams. Runoff consists of precipitation that neither evaporates nor penetrates the surface to become groundwater. Even the smallest streams are connected to large rivers that carry billions of gallons of water into the oceans worldwide. Excess runoff can lead to flooding, which occurs when there is too much precipitation.
Thanks for coming to our pool party.
Because pools are water too.